Yeah, yeah, good evening all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Oh, your screen is visible for me.
Yeah, fine, thank you. So what is big data? Why Hadoop and Spark? Drawbacks with the current databases. Drawback with the current databases. Advantages. Hadoop and Spark. Scope and job market. Hadoop and PySpark. Yes. So what is big data? Why is Hadoop? Why Hadoop and PySpark? Drawbacks with the current databases. Advantages of Hadoop and PySpark. Yes. Scope and job market of Hadoop and PySpark. Yes. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes in different technologies, right? Yes. So this is what I'll be discussing, right? So here in this course, you'll be learning about four things here: big data, that is Hadoop, PySpark, Linux, Python. Yeah. Starting with the big data. Starting with big data. One second. Big data, the name itself saying like huge volumes of data. Currently, how the data is getting stored. The data storage units, right? You should have seen KBs of data. You should have seen MBs of data or GBs or terabytes of data. But today, data is getting generated in petabytes. Data is generated in petabytes, right? 1 petabyte equal to 1024. 1 petabyte equal to 1024 TBS. Means, yeah, 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, but petabyte equal to 1024 TBs. So examples of petabytes of data generation. Pet examples of petabytes of data generations, right? We take example of any banking sector like SBI, any banking sector, right? Like SBI or HDFC. Within the city, you see hundreds of branches of SBI. Within the entire state, you see thousands of branches. Within the entire country, lakhs of branches for SBI. Again, within each branch, millions and trillions of customers, right? Again, they are making multiple transactions per hour, per day, per week, per month, year, right? So huge data is getting generated. Forget about this banking sector, but you are aware about social media like Facebook. Facebook has got users not only within the country, entire world. It has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many posts and videos are getting circulated in a minute? Huge data, right? So Facebook generating data in petabytes. Not only Facebook, today if we talk about different applications, then generating data in petabytes. Facebook, if I take 1 minute transaction, 1 minute transaction, if I take 1 minute transaction, what is the data generated by Facebook? What is the data generated by Twitter tweets? What is the data generated by Google queries? Today, everyone are querying in the Google, right? What is the data generated? Data generated by Google. And YouTube videos upload. What should be the storage capacity to store all the videos, right? Email or Gmail messages. Storing millions and trillions of users. There's now is talking about bank transactions, telecom transactions, bank transactions, telecom transactions. We talk about the Flipkart and Amazon transactions, e-commerce transactions. Everywhere we see like huge data is getting generated in petabytes. Currently, we have got databases. Currently, we have got databases, right? Databases like Oracle, MySQL, DB2, SQL Server. Currently, we have got databases like Oracle, MySQL, DB2, SQL Server, right? Yes, for OLTP operations. Yes, currently we have got databases. Currently, we have got, okay, for OLTP operate, and we have got some specialized databases. We have got some specialized databases. We have got some specialized databases which are used for data warehouse operations, right? Like Teradata, Netija, Vertica. Yes, specialized databases like Teradata, Netija, Vertica. All these they are used for OLAP operations. They are used for online analytical processing. Either these databases or specialized databases, they can handle data up to some extent, but beyond that, it cannot handle, right? Means if it is data in petabytes. So, so as a solution to this storage level problems and processing level problems, right? We have got a framework. We have got a framework like Hadoop for unlimited data storage and processing. I'll come back to this, right? I'll come back to this, but today I'll see. Today, if you see, this is your data. This is your data available in the current real world. This is the data. This is available in the current real world. It is from the year 1975 to 2025. Mm. If you take the last 10 years, 2015 to 2025, and the previous 40 years, the previous 40 years, the last 10 years, 2015 to 2025, the last 10 years, the previous 40 years, if you compare the data, right, the data generation, nearly 80% of the data what we are seeing in the current real world has been generated from the last 10 to 15 years. The previous 40 years, only 20% of the data has been generated. And that too, if you see, like GBs, TBs, or petabytes of data has been generated from the last 10 to 15 years. Previously, if you see, if you go back like 1990s or the earlier 2000s, you got to how you used to carry the data. You got floppy disks like 1.44 MB. Later, you got compact disks in GB in MBs. Later, like DVDs. Later, you got USBs. Right. So day by day, the storage systems were increasing enormously. Now data has not reached terabytes, petabytes it has reached. Petabytes of data is getting generated. So for a huge data storage and processing, we need to have some proper storage systems. Reasons for this huge data generation, especially from the last 10 to 15 years, because of usage of technology, right? Because of usage of smartphones, because of usage of internet. Today, go back in 1990s, nobody knows about that internet. Now, everyone carrying internet, right? Smartphones, because of usage of technology, data has increased a lot. Previously, if we talk in the earlier stages, when the mobile phones were introduced in the early 2000s, to go back like 2001 or 2, see the internal storage was 128 MB or 256 MB. Now even 128 GB is a very small storage. In the coming years, it is going to reach terabytes and petabytes. So what are the main sources from where this data is getting generated? Mainly three sources of data. Mainly three sources of data. We say like social data. We say like social data, machine data, and transactional data. Social data, machine data, and transactional data. See, social data which has been generated from social websites, from Twitter, Facebook, all these things, right? Machine data means data which has been generated by reading, by scanning the RFID chips, barcodes, right? Go to a shopping mall for the items you purchase, a huge data is getting generated. Transactional data, day-to-day transactions. And if you talk about this, maybe three categories, three types of data. Three types of data categorized into three types. Structured data, which is organized in the form of forms, like database tables, size. Semi-structured data which is fully unstructured, like XML files, JSON files, and structured data, unstructured data, chart articles, images, videos, all this comes out. But the biggest challenge is how to handle and process, how to handle this unstructured data. Databases handle what database can handle only structured data. They can handle unstructured data, but Hadoop can handle all ways of data, structured, unstructured, and semi-structured. So as data is increasing enormously, we need to have storage system processing data. What a framework about it. Hadoop performs both storage and processing. Hadoop is able to perform storage and processing. For storage, that's okay. So if we talk about technology, it is either meant for storing or processing. About C++, Java are meant for processing. About MySQL, DB2, SQL Server, all this they are meant for storage. All this they are meant for storage. Either they are meant for storing or meant for processing. But forms both processing. Does Hadoop use database storing its data means? No. I said has some drawbacks with the databases. Despite of the drawbacks, Hadoop doesn't use any database for storing its data. Rather, going with the kind of file system, distributed file system. There is a file system called Hadoop distributed file system in a database. And for processing, does Hadoop technology like Java is going with an execution model like MapReduce, but currently it is going with Spark. So it's for storing and for processing. So if you take a big data, huge data generation, if you take big data as a problem, the Hadoop is the solution. If you get then it's Hadoop as implementation. Yes. You may ask what are the drawbacks of databases? Databases are widely used and drawbacks of the databases as compared with Hadoop. Why databases can't be used for storing Hadoop data?
Because Hadoop stores huge data.
Yes, unlimited data storage. So drawbacks with one by one drawback. Current databases, right? Drawbacks with the current databases. First thing is limited storage, limited unlimited storage. And it's no parallel processing in most of the databases. And yes, in the drawback and databases, yes, volume of the data is increasing. If volume increases, or if data increases, speed decreases in databases. If the data is increasing, for example, trying to direct, I want total amount generated. So from sales one, task got 10 records. Total amount from sales one, which records sales to which has got 10 lakh records. Total amount, select amount, total amount from sales 3, which has got 10 crore records, 10 crore records. So here, if you observe to answer which query executes faster among these three, which query executes faster because total of 10 records, amount from 10 records as compared with 11 crore records. The first query executes faster. All right. So query to query of data is increasing, speed is and one more. If for example, take a labor example, a person or a boy, if he's carrying 1 kg, he can run with that, he can run with that. That's it. If that value increases to 10 kgs, he cannot run, but he can walk with that. But if it's increased to 3 kgs, not even walk. What is that? If that volume is increasing there, the speed is increasing, right? The same way here, value increasing, even complexity increases. If complexity increases, right, speed decreases. Yes, for example, even take a level. Try to answer for this. What is 3 into 4? 2. 2 that's fine. 2 into 6.
7 into
That's fine. 23 into 32. Try to say.
and take time.
524 into 1132. 1083 into 9376. So here, complexity increasing, your speed is decreasing, right? Complexity increase, speed is there. Here also, if I take labor example, if I take an example, that is database point of view, take an example. I'll take the same query. Total amount from sales one. Total amount from sales one, right? Yes. Assume it has got 10 lakh records. It has got 10 records. Same, I'll go with the operation. Average amount from sales one. Again, same 10 lakh records. One more. Select this time and deviation amount. Yes. From sales one. Which query? Or average amount of deviation. Three queries. Which query? First, right? First, average amount of two-step process. First sum has to calculate as compared with that first query, second query or not. This third query is standard, a lot of internal processing is required. And if the major drawback with databases is that databases can handle or RDBMS data. They cannot handle unstructured data. You want to use a particular movie. If data structured form of rows and for example, user one column, user and subset. So in this, user to user. They are giving the review of zero. The movie is saying zero. The movie is good, saying the movie is good, saying the movie is saying zero. Therefore, they're saying from zero cents. Can you write it to count the zero cents? To count how many goods and how many not goods? Can you write it to count the number of zeros? Aggregations, grouping and aggregations, right? Single grouping and single aggregation. Select twice. By one. Reduce. Group by review. Review count by review. Review as by review. Output. Review spins 1 and 0. How many in ones? Say that 90 you got. This 10 you got. 90 people saying the movie good, 10 people saying the movie is bad. So you can write this. You can handle this kind of data. But reviews won't be given in the form of zeros and ones, right? Reviews won't be given in the forms of yes. They give in their own text format. Movies. First person movie good. 10% saying movies in the same in their own text form. You can write an SQL query, count the number of numbers. You can write it. This kind of data not handle. But still, if you use count, okay, you can count. But still it gives wrong computation because not got it. It was wrong computation, right? Yes. That's what we should go by. Yes. So the drawbacks is there's no parallel processing storage. When increases speed, complex increases speed, data will handle only structured data, will not handle unstructured or semi-structured, right? Yes. Now, advantages of Hadoop. Advantage of Hadoop. Connect to Spark later. Advantage of first thing is unlimited data storage. Unlimited data storage is possible. Unlimited data storage. Secondly, very high speed processing. Very high processing. Unlimited data storage, very high speed processing. Because of this parallel processing, can handle all varieties of data. All varieties of data is an open source. This is an open source, no licensing rate, no licensing for this cost cutting. Right, and commodity hardware means it doesn't mean that you need to have very high configured systems, but you can install in any hardware. So unlimited data storage is possible. Very high speed processing can handle all varieties of data. Open source, no licensing, right? Yes, these are the advantages. Unlimited very high processing. The file can handle all varieties. Structure. Also no licensing. Most product from Apache. You can take it side. Commodity, right? So one example, right? So Yahoo has conducted a test. Has conducted a test right, to check the speed of different databases. Has taken a table of 100 TB, then consisting of 1,000 kilobytes. So that is sorting based on 16 params. Sorry, based on 16 params. Sorting based on 16. Yes. So what is the time taken by different databases? Time taken by different databases. First, Oracle nearly 3.5 days processes. MySQL has taken nearly 6 days. Specialized database has taken 4.5 hours. Right. Another data warehouse has just has just taken 3.4 minutes. Has just taken 3.4 minutes of time, right? The latest version of Hadoop has taken 1.2 minutes. This is what the speed of Hadoop as compared with other things. So these have taken minutes of time. Those have taken days of time, right? So Hadoop is proven from storage point, right? If you also have provide some in the tomorrow issue, how Hadoop is proved in the market. So of you passing point with rate of speed. Yes. Now if I talk about Spark, this Apache why PySpark? Why PySpark? Need for PySpark. PySpark features. The real life usage of PySpark. PySpark job market. PySpark job market. Yes, what is Apache Spark? What is the need for PySpark? All right, PySpark the features, real life usage of PySpark, and this market, right? Yes. Okay. What is Apache Spark? What is Apache Spark? It is an open source distributed cluster computing framework introduced by Apache software. It is a general engine, I can say. It is a general engine for data analysis, big data analysis, for processing and for computation, right? Yes. See, we say why PySpark today? Why it is the Python API. PySpark is the Python API to use Spark. Spark is an open source. I said it's a cluster fitting used for big data solution. You can say PySpark, the lightning fast technology has been designed. It's a very dynamic technology to work with this. Spark running distributed SQL. PySpark used for running distributed SQL. Using databases into database, running ML algorithms, working with graphs, or data streams, running distributed SQL, creating data pipelines, ingesting data into a database, running ML algorithms, working with the graph or data streams. Need for PySpark. A large amount of data is generated offline and online. This data contains hidden patterns, interactions, market trends, preference, useful business information necessary to extract valuable information from the data. Right. So efficient tools for performing these different types of operations as huge data. So you may say that you have got all the tools for performing this operation, this huge data, but the tool that so much of appealing, right, is so we require some flexible to grasp big data and gain it from it. So Python, right, is a lightning fast technology. It's such a technology, right? Which will be insights from the data. So combining Python will be the very efficient for the big data. That's why Apache Spark community and people called PySpark. Very high speed processing, I said. Very high speed. Okay. And if you see, I'll be discussing the main time, but what are the real of this PySpark? Real of usage. In the commercial sector, it is the commercial sector. Like the bank is using Apache Spark today to the customers, social media, and also analyzing insights which are taking the right decisions, and also in risk assessment, fraud detections, and also use ethic care also, right? Yes. To analyze patients' records along the to identify which patient is probably to health issues when being discharged from the clinic. And if not like entertainment aspects. So today, if we talk about the entertainment industry, is moving towards this on-screen platform like Netflix, Spark for this real-time process for the movies, which can process nearly 40 billion events per second over server-side application, trade and e-commerce. e-commerce. So e-commerce websites like Flipkart, Amazon, all these things, Apache, when other websites provide offers and enhance experience, optimizing the overall performance in the tourism industry. In the tourism industry, right? It's that is part used to provide advices to millions of travelers by comparing hundreds of tourism websites. So in this way, right, the usage of content. That's what of this was Durga. So Spark with Python like Python. So it's not a flex. Right. This Python you'll be doing this code and also Python. The lectures will be there on this. So for this Python, you are supposed to attend any Python beside the course. Python, if you want to go with the Python bash, AM in the morning. 1 p.m. Evening if you want to go with like morning means 8 a.m. But the timing of this will be it's an initially it will be for week it will be 8 a.m. It will be shifted to 8 a.m. but it's 9 p.m. to get 8 p.m. Right? Yes. But big data, Hadoop, PySpark, and Linux in this durations of these weekends. So the impact of this will be 5 a.m. to 7 p.m. Right. So tomorrow also if we can at same time at 40 to see more discussion on before the course content of it. So it goes for weekends, right? 12 weekends around 3 months it takes. So yeah, observe this course about this. Starting with productivity on sources, challenges, RDBM, advantages of HDFS, to know about this HDFS, configuring block size, name node, architecture, manage bridge processing, applications, fault tolerance, map. Yes, another important component importing and exporting. Importing from storing from Hadoop to database. During this import operation, nothing for combined, filtering, matching against right. Yarn and how to write scoop jobs and yarn get another source negotiator. Executions, clear job, clear task, yarn plans, consequences, the single and latest actually to be discussed. Matching this Hive architecture, Hive meta. You see, lot of jobs. If you have got knowledge of this, only this component. Just check Hive job. Just 5,057 Hive only Hive jobs on site. So we'll be discussing in brief of Hive metas, query language, SQL, and Hive HDFS, XML data on the URL and weblog, existing to HDFS, Hive UDF, Hive UDF, UTF, partition, non partition, dynamic partition, performance tuning management, bucketing in Hive, indexing, Hive examples, right? Also, given knowledge on this streaming data plans like Kafka. Streaming data means data which keeps on waiting, data which keeps on incrementing such data we call testing data, using Spark, in brief, Spark, if I use partition, context, repartition, broadcast, Spark, recomputation, artificial recomputation, persistence, this only, computing and way of creating what is create increasing number of partitions, aggregations, single grouping, single aggregations, multiple aggregations, process by key reduced by various access and transformations, found by key, found by group, Spark, SQL data frame, creating a data frame, and the data frame to us shows class, select with quality name, variable drop sorted by sort for signals and the spice park is functions and functions different time functions JSON functions spice park build functions when can get string translate overlay different months between so different functions and external source spark and integration spark and MySQL integration so CSV transformation actions and narrow transformation action of new columns dropping of columns handling nulls writing a back external source of tables from database and local mode load cluster applications, right? Stays and execute Spark applications, deploy Spark applications to cluster and performance in Kafka, Python streaming components, Spark ML, and so Python present knowledge on this Python. What is Python? Python features, advantages, history, efficient flavors, Python operations, log, data IDs, data types, constants, data conversions, escape sequences, IDs, flow controls, looping strings, collections, Python lists, Python tuples, sets, dictionaries, functions, bonds in package in errors exception and handling, between programming for stable expressions, database activity, Python data and time, advanced concepts like iterators, generators, and filters, Excel book, data analytics, data science model. This is what this Python. If I said nearly 50 cents for Python, and for this Hadoop, Spark and Linux, 12 weekends it goes. So 15,000 is the cost for it. For this Spark, Linux, and Python. Inequalities, right? So tomorrow session, same timing, 4:30 p.m. using the same link to see what is fine. So it's appreciation like what is big data, Hadoop, what Hadoop is, what features, right? That's briefing you about. So tomorrow session where we have stopped. Then I'm stopping for now. Right. We'll continue tomorrow. Thank you all for your time.
Thank you so much for valuable those.
Yeah, bye.
It's a brain fixer.
Thank you. Yeah. Yeah. Good evening, all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Wow, your skin is visible for me.
Yeah, fine. Thank you. So what is big data? Why Hadoop and Spark? Drawbacks with the current databases. Drawback with the current databases. Advantages. Hadoop and Spark. Scope and job market. Hadoop and PySpark. Yes. So what is big data? Why is Hadoop? Why Hadoop and PySpark? Drawbacks with the current databases. Advantages of Hadoop and PySpark. Yes. Scope and job market of Hadoop and PySpark. Yes. So myself, I'm Vijay. Like I hold 20 plus years of experience, which includes in different technologies, right? Yes. So this is what I'll be discussing, right? So here in this course, you'll be learning about four things here: big data, that is Hadoop, PySpark, Linux, Python. Yeah. Starting with the big data. Starting with big data. One second. Big data, the name itself saying like huge volumes of data. Currently, how the data is getting stored. The data storage units, right? You should have seen KBs of data. You should have seen MBs of data or GBs or terabytes of data. But today, data is getting generated in petabytes. Data is generated in petabytes, right? 1 petabyte equal to 1024. 1 petabyte equal to 1024 TBS. Means, yeah, 1 petabyte equal to 1024 TBS. 40 last page but petabyte equal to 40 TBs. So examples of petabytes of data generation. Pet examples of petabytes of data generation. Example, banking sector like SBI. Any banking sector like SBI or HDFC. Within the city, hundreds of branches of SBI. The entire state, you see thousands of branches. Within the entire country, lakhs of branches for SBI. Again, within each branch, millions, trillions of customers, right? Again, they are making multiple transactions per hour, per day, per week, per month, year, right? So huge data is getting generated. Forget about this banking sector, but aware about social media like Facebook has got not only within the entire world, it has got millions and trillions of users throughout the world. What is the data generated by Facebook in a minute? How many people generated in a huge data? So Facebook generating data in petabytes. Not only Facebook. Today, if we talk about different applications, they generate data in petabytes. Facebook take 1 minute transaction, one transaction fake. 1 minute transaction. What is the data generated? What is the data generated by Twitter tweets? What is data generated by Google queries? Today, everyone are querying in the Google, right? What is the data generated? Generated by Google. The videos upload. What should be the storage capacity for all the videos, right? Email or Gmail messages storing millions and trillions of views. Yes, now has talking about bank transactions, transactions, bank transactions, about the Flipkart or Amazon transactions, e-commerce transactions. Everywhere we see like huge data is getting in petabytes. Currently, we have got databases. Right? Databases like MySQL, DB2, SQL Server, 20 databases like Oracle, MySQL, SQL Server, right? Yes. LTP. Yes. Databases. Currently, we have got okay for OLTP operate, and we have got some specialized databases. We have got some specialized databases. We have got some specialized databases which are used for data warehouse operations like Teradata, Netija, Vertica. Yes. Specialized databases like Teradata, Netija, Vertica. All these they are used for OLAP operations. They are used for online analytical. Either these databases are specialized databases, they can handle data up to some extent, but beyond that, it cannot handle, right? Means if it is data in bytes. So, as a solution to this storage level problems and processing level problem, we have whatever like Hadoop for unlimited data storage and processing. I come back to this, but today if we see this is your data, this is data available in real world. This is the data in the real world. 1975 to 2025. If you take the last 10 years, 2015 to 2025, and this is the last 10 years, 2015 to 2020, last 10 years, the previous 40 years, you compare the data generation, nearly 80% of the data what we are seeing in the current data 10 to 15 years, the previous 40 years, only 20% of the data has been generated. And if you see, like GBs, TBs, petabytes of data has been generated from the last 10 to 15 years. If you go back to 1990s, the earlier ones, you got to how you had the data. You got like 1.4 disks in GBs, DVDs. So you got USBs. So the way the storage system is enormously. Now data is not reached terabytes, petabytes it has reached. So for huge data storage and processing, we have proper storage systems. Reasons for this generation, especially for last 15 years, because of usage of technology, usage of smartphones, because of usage of internet. Today, go back in total amount from sales one which has got 10 records, sales two which has got 10 lakh records, total amount, select the total amount, total amount from sales three, which has got a 10 crore records. So here, if you observe, try to answer which query executes faster among these three. Which query executes
First one.
the first one, right? Because total amount of 10 records, total from 10 records as compared with 10 lakh or 10 crore records. The first query executes faster because of its less data. So query to query of data is right. And one more, if volume is increasing, if you take a labor example, if it is carrying just 1 kg, he can run, it can run. If the volume increases to 10 kgs, he cannot run, but he can walk with that. But it is increased 70 kgs, he cannot even walk. Means what is that? If the volume is increasing there, the speed is decreasing there for the person, right? In the same way here, meaning, and if we take even complexity increases, if complexity increases, right, speed decreases. Yes, for example, try to answer first. What is 3 into 4?
12.
12, that's fine. 4 into 6,
72.
that's fine. 23 into 32, try to say.
And take time.
524 into 732. 1083 into 9376. So here, complexity increasing, your speed is decreasing, right? If complexity increased, speed is in the same way. Here also, if I take a labor example, if I take an example that is database point of view, if I take an example, I'll take the same query, total amount from sales one, right? Yes. Assume it has got 10 lakh records. Same, we'll go with the average amount from sales. Again, same records. One more. Select this time standard deviation of amount. Yes. Which executes faster here? Sum of amount or average or standard deviation. Three queries. Which query executes faster? First query, right? Obviously, the first query, because amount two-step process. First sum has to be calculated, average to be calculated. As compared with that first query, second query, more time or not? This third query, standard deviation of amount, lot of internal process required. And if database is the fifth one, databases can handle, or RDB can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. You see an example for this. You want to take a reviews for a particular movie. If data is in a structured form in the form of rows and columns, for example, user is one column, review is one other column, user and the review. Just observe. So in this way, user one, user two, user three. In this way, 100 users. They are giving the review in the form of zeros and ones. If the movie is bad, saying zero, the movie is good, saying one. If the movie is good, saying one. If the movie is bad, zeros and ones. Therefore, they're saying in the form of zeros and ones. Can you write an SQL query to count the number of zeros and ones? to count the how many goods and how many not goods. Can you write an SQL query to count the number of ones and zeros? Aggregation, grouping and aggregation, single aggregation. Try to set, revise, count I want. From which group by review. Select revise from group by review. Revise count from review. Output 1 and 0. Review spins 1 and 0. How many in ones? Say that 90 you got. This 10 you got. 90 people saying the movie good, 10 people saying the movie is bad. So you can write this, you can handle this kind of data. But generally reviews won't be given in the form of zeros and ones, right? Reviews won't be given in the forms of, yes. They give in their own text format. Movie is, for example, first person saying movie is good. Second person saying, okay, movie is not good. In the same way, in this, they're giving in their own text format. Can you write an SQL query now to count the number of goods and not goods? Can you write a, this kind of data you cannot handle, right? But still, if you're using this keyword counter, okay, good you can write, but still it gives wrong computation because not good has got good in it. So it gives wrong computation, right? Yes. Review as count from reviews group by review. Yes. So the major drawbacks is database, no processing, limited storage, volume increases, speed decreases, complexity increases, speed decreases, and databases can handle only structured data. They cannot handle unstructured or semi-structured, right? Yes. Now, advantages of Hadoop. Advantages of Hadoop. I'll come back to Spark later. One second. I'll have separate advantages of Hadoop. First thing is unlimited data storage. Unlimited data storage is possible. Unlimited data storage. Secondly, very high speed processing. Very high speed processing. Unlimited data storage, very high speed processing because of this parallel processing. Can handle all varieties of data. Can handle all varieties of data. Is an open source. This is an open source, no licensing rate. No licensing for this cost cutting. So right. And commodity hardware. Commodity hardware means it doesn't mean that you need to have very highly configured systems, but it can have in Hadoop can be installed in any hardware. It can run on any hardware, right? So mainly unlimited data storage is possible. Very high speed processing can handle all varieties of data. Open source, no licensing, right? Yes. These are the advantages, right? Unlimited data storage is possible. Very, very high speed processing because of parallel processing can handle all varieties, structured, unstructured, semi-structured, open source, no licensing. Most of the products of this Hadoop are from Apache. You can take it from Apache Mirror's website, commodity hardware, right? So very high speed processing. One example, right? So Yahoo has conducted a test right, to check the speed of different databases. Has taken a table of 100 TB. Has taken a table of 100 TB consisting of 1024 columns. So the task is sorting based on not a single column, sorting based on 16 columns. Sorting based on 16 columns. Sorting based on 16 columns. Yes. So now what is the time taken? Time taken for different databases. Time taken read by different databases. First, Oracle. Oracle has Oracle has taken nearly 3.5 days to process this. MySQL. MySQL has taken nearly 6 days. Teradata, a specialized database used for data warehouse, has taken 4.5 hours. Right. Netija, another specialized database used for data warehouse, has just taken 3 hours, right? Finally, Hadoop has just taken 3.4 minutes. Has just taken 3.4 minutes of time, right? The latest version of Hadoop has just taken 1.2 minutes. So this is what the speed of Hadoop as compared with other things. So very high speed processing, these have taken minutes of time, but those have taken days and hours of time, right? So Hadoop is proven in the markets, processing point of view, even storage point of view, right? Uh, Storage point of view also, I'll provide some examples, right, in the tomorrow session, how Hadoop is proved in the market, storage point of view, processing point of view with a very high rate of speed. Yes. Now, if I talk about this Spark, what is Apache Spark? PySpark. Why PySpark? Need for PySpark. PySpark features. Real life usage of PySpark. PySpark job market. PySpark job market. Yes, what is Apache Spark? What is the need for PySpark? All right. PySpark features, real life usage of PySpark, and its job market, right? Yes. Okay. What is Apache Spark? What is Apache Spark, right? It is an open source distributed cluster computing framework, right? Introduced by Apache Software Foundation. It is a general engine, I can say. It is a general engine for data analysis, big data analysis, for processing, and for computation, right? Yes. See, we say why PySpark today? Why it is the Python API. PySpark is the Python API to use Spark. Spark is an open source. I said it's a cluster computing used for big data solution. You can say PySpark is the lightning fast technology that is being designed for fast computation. It's a very demanding tool among the data engineers to work with bigger data sets. PySpark used for running distributed SQL. PySpark used for running distributed SQL. Creating data pipelines. Ingesting data into databases. Into a database. Running ML algorithms. Running ML algorithms. Working with the graphs. Working with the graphs or data streams. Running distributed SQL, creating data pipelines, ingesting data into a database, running ML algorithms, working with the graphs or data streams. Need for PySpark. A large amount of data is generated offline and online. This data contains hidden patterns, unknown corrections, market trends, customer preferences, other useful business information necessary to extract valuable information from the raw data. Right. So we require some efficient tools for performing these different types of operations on this huge data. So you may say that you have got already tools for performing these kind of operations on this huge data, but the tools are not that so much of appealing, right? It is so we require some flexible tools to crack this big data and gaining benefit from it. So PySpark, right, is a lightning fast technology. It is such a kind of technology, right? Which we can get many insights from this data. So combining Python and Spark will be the very efficient for the world of big data. That's why Apache Spark community came up with a tool called PySpark. Very high speed processing, right? Very high speed processing. And it takes time. But what are the real life use cases of this PySpark? Real life here. In the commercial sector, the commercial sector, like financial systems using PySpark to detect the social customers, this customer social media profile and analyzing again the insights which helps him take decisions. Also discusses and also in fraud detections widely used in machine learning tasks. Spark has got a special library like Spark email library. So healthcare it is used in healthcare, right? Yes. To analyze the patient's records along with the previous medical records to identify which patient is probably to face health issues even after being discharged from the clinic. And even if we talk like entertainment industry, right? Yes. See, today, if we talk about the industry, it's moving towards this on streaming. The popular platform like Netflix, using Apache Spark for its real-time processing, for personalized online movies, this process nearly 450 bytes that are streamed over that application, trade and e-commerce. Trade and e-commerce. So e-commerce websites like got Amazon, all these they offer this advertising, right? Even other websites like Alibaba, right, offers an enhanced customer experience, the overall performance in tourism industry. Even in the tourism industry, right? Yes, it's Apache Spark used to provide travels, comparing hundreds of websites. So in this way, right, the usage of Spark, that's what of this course data Hadoop, less. Spark with Python, we select PySpark. So yes, knowledge of Python, right? Within this Python, you'll be getting this both the core and advanced Python. Nearly 50 sessions will be there on this. So for this Python, you are supposed to attend any of my Python batch. I have this Python course. Python, if you want to go with this, there is a Python batch, 8 a.m. in the morning. You can attend this 8 a.m. or 9 p.m. Evening, if you want to, you can go with 9 p.m. Morning 8 a.m. But the timing will be at 7 a.m. Initially, it will be for 1 week, it will be at 8 a.m. We shifted to 8 a.m. But this 9 p.m. it will be at 8 a.m. Right? Yes. But as Spark and Linux, you will have sessions on these weekends. So the timings of this will be like 5 a.m. to 7 p.m. So also people can attend the session at same time at 4:30 to see more discussion on this. So before that, you can see that course content of it. So it goes for nearly 12 weekends, right? 12 weekends, around 3 months. So and observe content starting with big data. What is big data? Needs, sources, challenges, or deep advantages of HDFS or business to know this HDFS, block size, name node, HDFS architecture, metadata management, storage and processing, repeaters, fault tolerance, map reduce, phases of map reduce, right? Scoop other important comp, importing, exporting, importing database Hadoop, from Hadoop database. Doing this import operate many other things we can perform, like filtering, merging, grouping, aggregation, yarn, and how to write defining scoops and yet another. So basically to jobs, specific architecture, yarn, NoSQL databases. Advantage is NoSQL, different types of SQL, and one NoSQL database like HDFS and Apache Hive in this Hive architecture. A lot of have got knowledge on Hive and only just check Hive jobs. A lot of Hive. Just to check this 35, 37, I think only Hive covered on this Hive. So we need to have Hive language, SQL and SQL, Hive local files, local side load data tables, JSON data, URL and web log down, and setting to HTML, UDA, PDF, right? One part and performing mechanism in Hive, index Hive examples, Hive given just examples like Kafka. Data means data which keeps on generating, data which keeps incrementing. Such data we call it as streaming. How to calculate this like Kafka in this need for PySpark real life case, PySpark session, PySpark reporting, broadcast, PySpark quantity computation, computation, quantity persistence, memory only, memory underscore SCR only, PySpark core computing, different ways of creating oddities, increasing the number of partitions, groupings and aggregations, single grouping aggregations, multi-grouping aggregations, process of group by key, variations and transformation count by value, function group, PySpark data frame, asking a data frame, and converting data frame pandas, shows type, row class, count class, select, collect with column, name, then filter, draw, duplicate, sort, duplicate, UDF, map, simple, and PySpark functions, aggregations, window functions, timestamp functions, JSON functions, built-in functions where you are split, substring translate over different ones between, so different functions and express source, part navigations, part what is transformations and actions, addition new columns, dropping of columns, handling, writing data back, also creating of tables from database, and local mode, cluster mode, PySpark applications, and levels and executed against implementation with of the PySpark stream components, and also Python if it doesn't know Python features history, instructions, operations of IDs, data responsibles, type and descriptions, different object types, flow control statements, looping statements, such as Python lists, Python sets, dictionaries, functions, Python an exception. Finally, computer expressions, database activity, Python data and time. Also, iterators, generators, processors, work with Excel, data analysis, into data science, pandas model, and model. This is what we'll discuss. Then, identity sessions will be done now. PySpark, right? So, Windows supposed to be free. What's that? Data, PySpark, Linux, and Python. Small organizations say IPM in the see more on this. So it's introduction like big data, Hadoop, what is advantages, features, briefing out. Right. So tomorrow continue more discussion we have, right? Yes. Stopping. Right. We'll continue. Thank you all for your time.
Thank you so much for available.
Okay. Bye.
It's a very brief introduction for you.
Thank you.